Hello everyone. What I will show you today is definitely something else, what you show normally. I'm not a computer engineer. I work in the field of cultural heritage. And this TNA is a partnership between the University of Applied Science in Neuchâtel and the École Centrale de Nantes. And I work with Florent Laroche. On this project. So my project is about the use of 3D imaging techniques to digitalize and visualize technical cultural heritage artifacts. What does that mean? Which object does that concern? So here we have some example of different objects, and you can see the difference of size of this kind of artifacts. So on the up left you have a watch with a tiny mechanism, so it's like a bracelet watch, so you can imagine how small all this mechanism is. You have also a typewriter, and on the right it's a sewing machine, and we can consider it like the ancestor of the computer, because you have a perforated cardboard on the left of the object, and the object is able to read all the hole, and at the end you have a pattern on your textile. So it's really, we can compare it like as a computer. So like you see, we have a different type of materials, different type of size, and it can be also bigger if we have ship, planes, car, or a whole industry. So to digitalize such object is not, we are not limited by the size. So what do we want to have a 3D model of such scientific and technical objects? We can have a lot of use of the 3D model, and I show you here some example of the goal of this digitalization. For example, we want to document and archiving the object at the time t. So I consider the time t as the state of an object, because I don't know if with the aging of the object you have a development of corrosion, for example, you have abrasion, you have loss of materials, loss of pieces, and we can document an object in a specific time, and that can be really useful for a museum or for the research. If we have this object in a specific time, we can also monitor its condition state using a topographic comparison. For example, if you compare a sculpture who are exposed outside, and you do a scan today and you do another scan, you compare it with a scan 10 years later, you can compare if this sculpture is being abrased or eroded by the weather, the rain, and the wind, and it can give you precious information how long the sculpture can live, or without the loss of some fine work on it. Also, it's more about the technical object, how it works. It's not always possible to understand and explain how an object is working if you cannot make it in working condition. With cultural heritage, sometimes it's not possible because you have missing parts, for example. So if you have it in a 3D, you can use it again and show to the public in a museum, for example, how a complex object is working. You can do also reverse engineering to make some simulation with a CAD software like Katia, and that help us to know, for example, if your object is actually working and what risk you face on if it works again. So if you have a clock, and if you can scan it and do some reverse engineering, you can simulate again the working condition, and to see if it's possible or not, what's the risk. And if you have missing parts, you can build a physical model using digital manufacturing, for example, a 3D printer. And we have also other examples, but it will last too long if I explain every idea we have. The methodology of the TNA was to test different scanning techniques on an object with representative of the specificities of scientific and technical heritage. I mean by that, for example, reflective surfaces, because all the objects are made of metals, and we know that it's not easy to scan metallic surfaces. We also want to save the historical evidence, like, I don't know, a scratch on a surface or stuff like that. We also have aged surfaces. We have rust, we have dust, we have dirt, lubricants, and so on. And all the parts also are independent and they can move. So all this information has to be saved in the 3D model. So I choose an object with representative with the problematics. Here you can see, if you follow my arrow, some specific surfaces. Here you have number. If you have two different metals with it's not the same surfaces. Here you have moving parts. You can see gears and also details. So we want to save a lot of information on the 3D models. So first of all, I had the opportunity to make a training school in the Koch project in Warsaw. And here you see how we work. We use a robotized structured light system. And they had to cover the object with a white powder. Here it's titan oxide, and that's not allowed. It's not possible to cover our object. Here it was a test object, so we did it, but it's not the solution. But still we did it for the test. So here is during the scanning, and you see on the left the robot arm, and the technique is really accurate. So it lasts long minutes, long hour to scan the whole object. So they use a robot arm and he do it automatically. So he scan every part of the object. That was made in the Warsaw University of Technology with Professor Robert Sitnik. And I cannot rebuild the whole model in 3D because of the time, and that was not really the purpose of the training school. We work on another model, but I just want to test my object there. And then after that, I decided to apply a TNA and also a short-term scientific mission held by the Koch program. And I had the possibility to go in Nantes, in the École Centrale de Nantes, and I test two other methods to scan my object. Here it was in Arcantic, and we test the photogrammetry. Here it was a Nikon D70 with a 60mm macro fixed focus, and you see on the left the camera and the photograph. And then we treated all the information. It was about 200 pictures. And here the result is a partial result because we didn't make the reconstruction with every picture because it took too long time. But here just to show, it's really interesting to see all the surfaces, the rendering of the surface is good, and we see really all these marks, the gears. Here we see some oil in the gears. That's really good. But the problem here is with the shiny surfaces. We can have some problem like here on the left. You see the surface look bump. We have some hole in the reconstruction because if we have a white reflectance in each picture, the computer cannot understand where is this pixel in the space. But it's only partial result, and we did a new campaign of photography in a better condition, and I hope I can have a better reconstruction soon. So then, here in École Centrale de Nantes with Florent, we test handheld self-positioning 3D laser scan from a Creaform. And we were not, trustful of the technique before, but afterwards we were quite happy with the result. And here you see it in process, and you have small white dots near the object that allow the scan to know where he is relative to the object. So we doesn't have we can move everywhere with the scanner, and it's really convenient. and you can see in the screen directly what we are scanning. So if we have some holes, we can stay longer in a specific place to fill the model. Due to the metallic surfaces, we had a lot of noise and wrong points here due to the reflective surfaces, and then we had to clean everything, but it was possible thanks to the data processing software. But still, it's a problem we faced on. Yesterday, I had here in Neuchâtel, in the University of Applied Science, someone from Creaform who make a demonstration with the new updated scanner, and we didn't have all these points, and it's quite a good news for the future for us. Here, in matter of the resolution, here you can see the gear, and we can see every teeth of the gear, and that's really good due to the resolution, and we can really separate each different pieces of the object. If decrease the resolution, you see that in a 0.4 millimeter, we still save the data we want. If afterwards we want to do reverse engineering, so we can distinguish the different parts. But the question is, does the profile of the teeth still right, or still right in comparison with the reality? And then if you decrease it again, you see that we really lose a lot of information. So for a technical object, it's really important that we have a high resolution during the scanning. Here you see if you have if you want to have the texture of the surface, we can face a problem because we are applying a red laser on it, and if we save it due to the reflective surfaces, we also save the red. So on the left, you can see really the texture we can save with the scanner, and it's useless. We have no information in it. It's more important to have the proper 3D model without the texture with such a scanner, and then maybe we can apply the texture using picture and so on, and it will be really better and will contain more information for what we need. Here it's during the reconstruction of the different STL files after scanning. With this scanner, it's really interesting because to reconstruct the whole object, we only had 3 different files, so 3 scans. So it was really quick to reconstruct, the whole object. The goal for me is, at the end, it's to use the 3D model to reconstruct it and having each part moving separately. And actually it's not possible if we only use a scan, so I have to use my file in a CAD software and redraw every part. So it's really time consuming. So that's why I didn't finish this work. But here you see the model in CATIA, and I am replacing it in the quiet orientation, and then I will be able to take measurement like a caliper in my object, and then redraw it really precisely. And at the end, I hope that I can have as soon as possible a proper CAD model that I can really use to make some simulation and to see if I can have some risk between these 2 gears, if I reuse it and stuff like that. Here it's only a test object, but this question is really relevant if it will be a real cultural heritage object. So for the further development, we want to have a new mission. I think maybe in January I will go again at the École Centrale de Nantes to go further in a reverse engineering. And then we will purchase a portable 3D scanner at the HEARC, the University of Applied Science in Neuchâtel. I will purchase one, and I think it will be also a Creaform. We are waiting from some offer, and we'll see if it be possible to have it till the end of the year. So that means that we can continue our work in Neuchâtel, and I hope I will motivate some of our students to make some thesis in these topics to go further. It's also very important to have to write some code of ethics around the 3D scan files, because all the software are modifying the scan, and we are filling holes and stuff like that. And it's very important for us in the cultural heritage and or for archive to only conserve the truth. So if we fill some holes, it's important that we have the information. So this point is not the reality. It's a point made by the software. Next year we are applying maybe for an internal university project here, also in Neuchâtel, around this topic, thematics, and we hope also to find a partner and new collaboration around this world of cultural heritage, and other development are in thinking right now. Here I want to thank all these people who welcome me in their university or museum or whatever, and also the two program, Visionair program. Let me present my my TNA today, and also I will present it during the General Assembly in Rennes. Maybe I will add some details for it, and also the course program, because the two programs allow me to work in these topics. Thank you very much for your attention. Here we have a small resume, an abstract of the work, but you saw it already. Thank you.